Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Abutiwa Sos, Ugobela Maths. And without any further ado, let's look at these questions that we have here. Okay, so we are still on statistics. And then we are given question 1. It says the matric class of a certain high school had to vote for the chairperson of the RCL, which is the Representative Council of Learners. The scatter plot below shows the IQ intelligence quotient of the 10 learners who received the most votes and the number of votes that they received. So we can see that scatter plot here of the number of votes versus the IQ. Then before the election, the popularity of each of these learners was established, and the popularity score out of 100 was assigned to each. So there were 10 learners, and then each of them had the popularity score. The popularity scores and the number of votes of the same 10 learners who received the most votes are shown in the table below. Right. Then 1.1 says calculate the mean number of votes that these 10 learners received. Right. So we have our calculator. I'm just going to take you through how you actually calculate that. So the first thing that you want to do is you press mode, and then you choose number 3 for stats. And then you're going to go for number 2, a plus bx. Right. So because you are looking for a stats of 2 variables, x and y. So this is the one that you're going to choose, right? So 2. And then now you can see you have x and y. So what you're going to do is you're going to fill in all these numbers here as they come, exactly as they are in that order. So you have 32, and then followed by 89, followed by 35. Then we have 82, and then we have 35, or 50, meant to say. We have 50, then followed by 59, then we have 81, then we have 40, and then 79, and then lastly it's 65. Right. So now you have entered all the ones for x. So now it's time to go to y. Then again in that order, it's 9, then 22, and then you have 10. So it's 9, 22, 10, and then we have 21, 11, 15, then 20, we have 12, then 19, and then you have 16. So after you are done, the one thing that you want to do is you want to check and confirm if everything that you've put in here is correct. So 32 goes with 9, and then 89 goes with 22, 35 goes with 10, 82 goes with 21, and then 50 goes with 11, 59 with 15, 81 with 20, and then 40 with 12, and then you have 79 with 19, and then 65 with 16. So everything is correct. Then you press on. So just like that, you have not lost your data. You can still retrieve your data by saying shift. And then once you see that S there, then you press 1. Right. Now you want to go to variables. Remember, what are they looking for? Mean number of votes, the mean number of votes. So the number of votes is represented by the letter Y. So if you are looking for the mean of the Y values, that means we are looking for Y bar. So we want to go to variable number 4. And then we are not looking for X bar because we are not trying to determine the mean of the popularity score. We are not trying to determine the mean of the popularity score. We are trying to determine the mean of the number of votes. So we are actually looking for Y bar. And then there you go. So your Y bar for 1.1.1, this is going to be Y bar is equals to 15.5, right? Then now you have 1.1.2. It says again the standard deviation of the number of votes that this 10 learners received. The number of votes. So again, we are looking for the standard deviation of Y. So we are going to say on, and then again shift 1 for stats, and then 4, and then we are looking for number 6, standard deviation of Y. So we have our standard deviation for Y is 4.59 if we round off to 2 decimal places as per instruction of the exam. Then 1.2, the learners who receive fewer votes than 1 standard deviation below the mean were not invited for an interview. How many learners were invited? First thing that you need to understand is this language here, right? The way in which they express this question. Now, if they say 1 standard deviation, 1 standard deviation below the mean, understand this. This is what is expected from you. So 1 standard deviation below the mean, that's Y bar minus 1 standard deviation. So I would write 1 minus the standard deviation, but then we know there's a coefficient of 1. Had it said 2 standard deviation below the mean, I would say Y bar minus 2 standard deviation. 3 standard deviation below the mean, it's Y bar minus 3 the standard deviation, right? And then if we have 1 standard deviation above the mean, 1 standard deviation above the mean, this is what you should write. And then that's Y bar plus that, right? So 1 standard deviation below the mean, it means that you take the mean minus the standard deviation, and then 1 standard deviation above the mean, it's the mean plus the standard deviation, right? So it's based on this. If they say 1, obviously there's a 1 here. If they say 2, you'd put 2 here, and then even here you'd put 2. But then I'm using this one because I'm simply looking at the ones for the Y values. If you were looking for the ones in X values, then this would become X bar minus the standard deviation of X. And then also here X bar plus the standard deviation of X, right? So please note this. Please note this somewhere in your book. And then, okay, now let's answer this question. Now that we understand what needs to be done, let's now answer that question. So the one thing that we have to do is Y bar minus that, and then we try to find the value that is within 1 standard deviation. So it's 15.5 minus 4.59, right? So you punch that into your calculator. So that's 15.5, 15, whoa. 15.5 minus 4.59. Okay, so I get 10.91. Now the 10.91 is not your answer. What you're trying to get here is you want all the values that are below this number here. From the number of votes, the Y values, you want all the numbers that are below this number, because all the numbers that are below this number represent the ones that got voted that are less than that number. So what are we trying to find actually? It's how many learners were invited. So that means the ones that got below 10.91 were not invited, and the ones that actually got greater than 10.91 were invited. So these ones invited, and these ones were not invited. So not invited. So if we have to exclude the ones that were not invited, then we can see it's the 10. 10 is lower than 10.91, and then also 9 is lower than 10.91. So that means these 2 here were not invited. So we have 10 learners, that means out of the 10 learners, only 8 learners were invited. So we want to represent that by saying 10 minus 2, and then it's equals to 8. 8 learners were invited. So the 2, unfortunately, couldn't get the vote that were necessary for them to be invited to the function, right? Or to the interview. It's an interview. Okay, so 1.3 says determine the equation of the least square regression line for the data given in the table. So as we saw with what we chose there, the formula for that is a plus bx, which most of the time we then write it like this so that it can be in the form of y is equals to mx plus c, because it's simply a straight line. Now, in order to determine this equation or this straight line, you need to first find the values of a and then find the values of b. As you know, with a straight line, we need to get the y-intercept and we also need to get the gradient. So our b here is more like the gradient and our a is more like the y-intercept. So what we do is, again, we get it from our calculator. Shift, and then 1. This time around, we don't go to 4, we go to 5. This is regression, right? So least square regression line, we want to get it from regression reg, then 5. So the values we are looking for is number 1 and number 2. I'm going to press number 1, and then this is going to give us 1.77. So always round off your values to 2 decimal places. And then again, we hit on, and then again shift 1, and then regression again. This time we write 2, and then b is 0.22. So that means our equation will be in the form of 0.22x plus 1.77. So that's it. That's our equation of the least square regression line. So I hope you are following as to how we get all of that. So once you know what to do with your calculator, then it is very, very much simple to pass statistics. Then we have 1.4 says predict the number of votes that a learner with a popularity score of 72 will receive. So from our regression equation, we can now predict that by saying the number of votes represents y, as we can see here, and then the popularity score represents x, right? So this is y is equals to 0.22. Where there is x, I will put 72, and then plus 1.77. Now, with the aid of the calculator, simply punch all of that. So that's 0.22 in brackets, we have 72, close brackets, plus 1.77, and then is equals to 17.61. But then we know that this cannot be representing the number of votes. You can't have 17.61 votes. So we need to write this in terms of an integer. So this is approximately 18 votes, right? Rounding off to the nearest integer. So it's 18 votes. Okay, nice. Then 1.5, it's saying using the scatter plot and table above, provide a reason why IQ is not a good indicator of the number of votes that a learner could receive, right? So the reason that is not a reliable piece of information or prediction, it's because, as we can see here, we can see that the values here or the points are all scattered, right? So we can mention that points are scattered all over. The points are scattered all over, and then therefore there is low correlation. There is low correlation. So if there is no correlation within the data or your points there, that means this information cannot be reliable, right? So it's showing the data is unrealistic. So unrealistic predictions. Unrealistic predictions. Because as we can see, the data is just all over the place. Then 1.5.2, the prediction in question 1.4 is reliable. So the prediction in 1.4, how can we ensure that it is reliable, or what tells us that it is reliable? Remember, the 1.4 is coming from the table, right? So if we've used the information on the table, in order to determine that this prediction is reliable, we can prove that by looking at the correlation value there, so which is R. So what you do here is again shift and then 1, we go to regression, but this time around we are looking for the value of R. The value of R will be the one that we comment with. So R is 0.98. According to the knowledge that we have about that value, we know that if it's closer to 1, it's 0.95 all the way. So between 0.95 all the way to almost 1, we know that if our regression line lies within this here, then this represents a very strong. So this is a very strong positive correlation. Positive correlation. Now, a very strong positive correlation means that we have reliable and realistic predictions. Reliable and realistic predictions. Right. So that's how you were supposed to tackle that question. And then now let's proceed to question number 2. We always know with stats we have question 1 and question 2. Okay, question 2 says a company conducted research among all its employees on what percentage of their monthly salary was spent on fuel in a particular month. The data is represented in the ogive, which is your cumulative frequency graph. And then 2.1 says how many people are employed at this company. We know that in order to get that, we just have to look at the maximum value of the ogive, right? So looking at this one, we can see the last point is that one there. We just need to extrapolate it to the y-axis. And then there we go, we have 60, right? So 2.1 will be representing 60 employees. So that means 60 employees are employed at this company. Then write down the model class of the frequent or of the data. So the model class is always the one with the highest frequency. So the highest frequency here, because this is an ogive, will be represented by the greatest gradient. So the one with the greatest gradient. So, or the one that will be representing the highest jump. The highest jump in values. Let's put that one in layman's term, in simple terms. So looking at this one, between the interval of 5 to 10, we can see that there is not much of a jump. It's from 0 all the way to 2, 4, 6. So we can say it's somewhere between 6 and 8 there, right? And then from here to here, you can tell that even here, there is not much of a jump. And then here, the jump becomes significantly greater, almost double this. And then here, when we check this one, we can see that the gradient here, the line here, the cumulative frequency line here starts to become much more steeper between this interval. So this interval is between here. The points are between 20 to 25. As we can see here, this here represents a greater gradient. There is the highest jump in the values here. So we're going to write that as x is greater than 20, but x has to be less than or equal to 25, right? So that's our interval for 2.2. That's the modal class. Remember, when we write the modal class, we write it in terms of the interval. So it's between 20 to 25. Then 2.3 says how many employees spent more than 22.5% of their monthly salary. So 22.5%, we know that it's between 20 to 30 there. If you can just say, between 20 to 25. If you can just say 20 plus 25 divided by 2, then what you will get is 22.5%. So which means 22.5% is in between here. So in order to get the number of employees that spent more than that for fuel, we just need to draw a straight line that will touch the ogive. And then from there on, we extrapolate that line to the y-axis. So there we go. And then extrapolate that line to the y-axis. So there we go. That's 32 and then 34. So it's hitting at 34. And then all the way up, it's the ones that spent more than 22.5%. Then the ones below 34 is the one that spent less than 22.5% of their salary on fuel, right? So that means in order to come up with that value, we need to then say, starting from 34 all the way going up here, starting from 34 all the way going up to 60, remember, we don't get to 70 because there are only 60 employees. So that means this is the number of employees that spent more than 22.5%. So to determine those ones, we say 60 minus 34, and then we'll be left with 26 employees. So that means 26 out of 60 employees are spending more than 22.5% of their salary on fuel. So that means maybe a lot of them live far away from the company. Then 2.4 now says an employee spent 2,400 of his salary on fuel in that particular month. Determine the monthly salary of this employee if he spends 7% of his salary on fuel, right? So if this here represents only 7%, we want to know the salary of which the 7% has been calculated. So we know that if we were trying to calculate this amount, it would simply be 7 over 100 multiplied by the salary, and then this would give us 2,400. But then now we are looking for the salary. That means we have to inverse this. Now this would become 100 over 7 multiplied by 2,400, and then we bring over the x to this side, which is the salary end. So if you punch that into your calculator, so let's make use of our calculator. We have so after you have done with the steps, you see when you're trying to press this, this is what happens. So in order to have your calculator back to normal, you need to press mode and then press 1 for comp. So when you press 1, it's now back to normal. If you press this, there you go. So this is 100. And then over 7. And then multiply that by 2,400. So this gives us a salary of 34,285.71. So this is the salary of the employee. Then, okay, we have 2.5. It says the monthly salaries of these employees remains constant, and the number of liters of fuel used in each month also remains constant. If the fuel price increases from 21.43 rand per liter to 22.79 rand per liter at the beginning of the next month, how will the above ogive change? So we know that this will affect the ogive in the fact that the ogive, so for 2.5, the ogive will shift to the right. Because now, remember, this the price that they spend on fuel will also be calculated to the same constant salary. So now that it has increased, or the money that will be spent on fuel will increase, then it will also increase the percentage. Because remember, as the fuel price increases, we are not increasing the salary. So this now becomes a larger percentage of the salary, because now it has increased and then still our salary remains constant. So we say the ogive will shift to the right, or it will become steep, So indicating that now they are spending more on fuel as a percentage to their salaries, right? So employees will be spending more on fuel as a percentage of their salaries. So if a particular employee was spending 7%, for example, if their salary is still the same and then we have increased the fuel price, you might find that now they're spending 8%, right, of their salary on fuel. Okay, so that's how you were supposed to tackle this question. All for a total of 20 marks. It was 12 and then plus 8 here. Then that's how you were just supposed to go about that one. So please press the thumbs up button if you've enjoyed the lesson and then you have found it helpful. And if you've been watching the videos and haven't subscribed yet, please hit that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.